Yesterday we talked about the periodic table and how I asked you to write 18 numbers across the top. The 18 numbers represent the groups. They're also known as families, and each family in the periodic table has specific characteristics that make it easier to identify where the element is from in the periodic table. So we know also that the periodic table is divided in two along this blue line. The elements on this line are called metalloids because they have properties that resemble metals and nonmetals. So the metals are found on this side of the table, on the left side. Nonmetals are found on the right side, and metalloids are sitting on the step or touching the bottom of the step, with two exceptions. Aluminum and polonium are actually it's probably more appropriate to think of them as metals, although they do have some metalloid-like qualities. For instance, aluminum is fairly high charge, and it oxidizes very easily. That's actually a metallic trait. Metals like to give up their electrons very easily, and they tend to be malleable, meaning when you hit them, they change shape. If you put them under pressure, metals actually deform. They bend. Whereas non-metals tend to just crumble if you hit them or if you put pressure on them. And metalloids have a little bit of both qualities. What else can we say? On the left side of the periodic table, the very far left, you have the most metallic elements. And what makes them most metallic is they have the properties that you could call metallic properties, like the ability to conduct electricity, the ability to undergo deformation, which we call malleability, the ability to be drawn into very thin wires without breaking. We call that property ductility. So metals have all these properties that make them very useful to us as materials for making mechanical devices and for structure. What's probably the most useful metal in your opinion? The most useful metal for humanity. The one we use the most for making. Titanium is pretty high up there, but I think there's something even more useful in titanium. You'll find all the really useful ones are strewn across here. They're all transition metals, or titanium, vanadium, chromium, manganese, iron. I would argue that iron is the most useful metal. It's not very attractive as far as metals go, but it can be, if you add a little bit of carbon to it, you can turn it into steel, which is a very useful metal because it's tougher than iron. And there are steels where they add other metals like cobalt and nickel. They can add manganese and chromium and vanadium, and if you add different metals to steel, to iron, you can get some very tough alloys. And that's what you call it when you mix two different metals. You call it an alloy. And some of the earliest alloys ever discovered were actually probably discovered by accident. One of the first alloys ever discovered was when they mixed tin and copper. When you mix tin and copper, you get bronze. And bronze is pretty tough metal. It doesn't rust. It doesn't corrode much at all. I mean, it might darken a little bit, but it doesn't really corrode. And you can make a pretty sharp edge on it. So you can make a sword out of bronze and sharpen it to a very keen edge, which makes it a very useful as a weapon. If you mix copper with zinc, you get brass. One of the more tough metal alloys is when you mix chromium and cobalt. It makes a super tough alloy. They use it for artificial hips. If you ever break your hip, sometimes, especially if you're too old, they won't bother trying to fix your original hip. They'll just cut it off and they'll put it in an artificial one. So they cut the head off your femur, and then they insert a conically shaped metal rod made of chromium and cobalt with a ball on it that looks like a hip, and then they put a plastic cup where your hip joint was, and it sits in that cup, and that's your new hip joint. They also use titanium, because titanium is very tough. It's a very tough metal, and it's light. On my motorcycle, I have titanium foot pegs. Just the part where you put your feet when you're standing up on the motorcycle, they're about that big, and they're really tough. The metal's really tough on them. You can drop the motorcycle on pavement, and even the motorcycle could slide across the pavement on the foot pegs, and the foot pegs will even make sparks, but they can resist being broken and dented and deformed, even though you drop the whole motorcycle on them. So that's probably why they use it, because titanium is really good metal for that kind of tough application. It can take a beating and not snap. If you had aluminum foot pegs on a motorcycle, the first time you drop the motorcycle, you'd break them. And if you had steel foot pegs, then the motorcycle tends to get heavier, because even though steel is tough, it's also heavier. So there's lots of technological applications for alloys where you combine different metals to form other new substances which can be tougher, or they can withstand corrosion. For example, if you put iron, cobalt, and nickel together, you get stainless steel. So if you have a sink, for example, you don't want your sink to rust, so they make it out of these three metals together, iron, cobalt, nickel, and when you put those three metals together, they don't rust. If you make just the right combination, you can get good quality cutlery. In fact, they usually will stamp 1810 on high quality cutlery, which tells you the percentages of cobalt and nickel. I think it's 18% cobalt and 18.8, not 1810. 18% cobalt, 8% nickel, or the other way around, I forget. And it creates an alloy of stainless steel which will resist rusting very well. You could put it in your dishwasher and so on, and because who wants to eat with rusty cutlery? That would be gross. They also have alloys that they use for example, dental gold. You know, if somebody gets a gold tooth, they don't just put straight gold in your mouth. They add other metals to it. I think sometimes they might add palladium. Where is palladium? PD. Palladium.
BE or BT?
No, it should be P something. Why can't I find it? Platinum, gold. Huh. I have to look into that.
I think it's 46.
There it is. Okay, sorry, yeah. Palladium with gold. They also make silver and gold alloys. And for mercury amalgams, the stuff they use in fillings, they actually have mercury, and I forget what other metals they mix into it, so they can push it into your tooth and it'll fill in the hole. That's the old-fashioned fillings. They don't do that anymore because obviously they tend to leach mercury over time, and then if the mercury gets into your body or your brain, it's not good for you. When I had old mercury fillings, and I had them drilled out and replaced with they're not as tough as the old ones, but they're also not as ugly, because the old fillings, you could see these black marks in your teeth, made your teeth look like you had serious problems in them. So 20, 30 years ago, it was the standard. They would just drill your teeth and put this a mercury amalgam in there to fill the hole. Typically, you don't want to be putting mercury in the body. I would have a problem with anybody who thinks injecting any form of mercury into the body is okay. And they still do it. They still do it with vaccines. They put forms of mercury in the form of thimerosal, for instance, as an antiseptic in the vaccines. I don't know if it's still legal, but until recently it was being done. So I don't know if it's been cut out. Yeah.
What does mercury do for people's body?
If you take mercury in your body, it damages your nerves from growing. It prevents your nerves from growing properly, and it damages your brain cells. So the more mercury exposure you have, the dumber you'll be.
So why do they put it in people's body then?
Good question. Why do they put it? Well, the original reason was they wanted to prevent vaccines from going bad on the shelf. So they put an antiseptic in there that kills germs. So it extends the shelf life and they can keep it on the shelf for longer without it going bad. So it's good for profits, because if you're gonna spend millions and millions of dollars to make vaccines, you wanna make sure they get to the people that you're selling them to. But it's like saying, here, we're gonna put a little poison in your food so it doesn't go bad. That's how it is. They do that, I mean, they do that. They put poison in food that kills germs. And there's no other way of saying it other than there is a light form of poisoning. Your body can deal with it most of the time, but good food goes bad quickly. That's how you can tell that it's good food. Some guy did an experiment recently with a McDonald's hamburger, where he or she left the hamburger in the closet for like 24 years. It didn't decompose. It dried out a bit, but it didn't decompose. Not even the germs want it. So what does that tell you about eating that kind of stuff? I mean, I don't think it's good for your health to eat fast food. In general, fast foods, I think, are probably not good for you because they put extra preservatives in them so that they don't go bad while they're sitting on the shelf, because they don't want to get sued by people who eat bad food and then sue the restaurant. So they make sure they put enough preservatives in the food that it doesn't go bad. But when you put too many preservatives, it's not good for your health. Because the same preservatives that kill the germs on the food, after you eat them, it kills the germs in your gut. And when you kill the germs in your gut, you're killing germs that are actually beneficial for you. They can keep you healthy. We need certain germs in our gut to stay healthy. And when you kill them off, you can end up having problems. You can even get into a depression. Did you know that? Some people get a depression from taking antibiotics. How does that work? Because they take antibiotics, it kills all the germs in their body, including the ones in their gut, which are beneficial, and then they're missing certain key nutrients that the body needs to make the neurotransmitters like serotonin, so they end up getting into a depression. So you can fall into a depression from having too many antibiotics. You should only take antibiotics when you really, really need them. Okay, let's keep on decoding this periodic table. The black writing means they're solids at room temperature. If they're in blue writing, it means they're liquids at or close to room temperature. If you have red, it means they're gases at room temperature. So you'll notice all these guys are gases at room temperature. They're called noble gases. And if they're in outline, it means that they don't actually exist naturally. They have to be made artificially through bombardment of other elements. So you can use neutron bombardment of elements to produce a new element. And how do you determine the name of the element? This is the key idea I want you to take away today. The name of an element is determined by the number of protons it has, and that's what this blue number here is all about. Notice how the numbers in blue go from 1, like a paragraph, like reading a paragraph. They start at 1, 2, 3, 4, 5, and they keep on going up by 1 until you hit 92, and then they still go up, but they're obviously not naturally occurring elements. So the blue number means how many protons the element has. The name of an element is based on how many protons it has. So if an element has 1 proton, it's called hydrogen. If it's got 2 protons, it's called helium. If it's got 3 protons, it's lithium, and so on. Okay, so what's your name if you have 40 protons? If you can read it from there.
ZR.
Yeah, ZR is zirconium. So zirconium has 40 protons. Technetium has 43. Technetium is a funny element. It's not naturally occurring, but it's way up there in the middle of the periodic table. There's a couple others that are like that. Francium is not naturally occurring. You can't find any francium on the Earth. So how come they put it on the periodic table? Well, because they knew something had 86 protons, and radon existed. They knew about it. And they knew about radium because it was discovered by Marie Curie, I believe. So they knew there had to be something with 87 protons. They never actually discovered it, but they knew it had to be possible for it to exist. So francium was known to exist when they understood how the inner workings of the atom were. And they said, yeah, there has to be an atom with 87 protons, but there's no actual francium that can be isolated. It's an extremely unstable element and highly radioactive, so it doesn't persist long enough. I mean, the longest lived isotope of francium is about 21 minutes half-life. So if you had a block of francium, half of it would be gone 22 minutes later. It would be turned into something else. And of course, if you had a large piece of francium, it would kill everyone because the radiation that it would emit would be lethal. Continuing then, the first group in the periodic table is called the Alkali Metals, which I showed you yesterday. I wrote it on the blackboard, Alkali Metals. The second group is the alkaline earth metals. Third group is the boron group. This is the carbon group. This is called the pnictogens, chalcogens, halogens, and noble gases. Now we're going to look across the periodic table, and I'll show you the transition elements, and I'll show you how to memorize the periodic table most importantly. So when you go across from left to right, you get potassium, calcium, scandium, titanium, vanadium, and so on. You can make it one big word. If you read left to right on the periodic table, you get He, Libabkinov, Nina Magal, Sipskal, R, Kasktiv Kur, Benfico Nakuzenge Jesberger. Make little words out of it and just read from left to right. You'll be amazed. You'll be able to memorize the whole thing and write it left to right. I continue. Herbs, Riesern, Matkro, Pedakadins, and Sibtexa. It says Balahafta Rias Erbt Auhag. And I stopped here because then the rest you know this way. Balgaintel, Carbon Silicazin Pub, Napaspi, Ostatepo, FCL Bryat, Hinartric Zern, H. Linak, Obedient Season Francium, and Bempester Barra. And Skylayak is good to remember. And Ferruas is good to remember too because it helps you line up here. Also notice the coinage metals, copper, silver, and gold. They're all lined up. All these metals were discovered from ancient times because they don't react with other metals very much. So you can actually find them in nuggets close to the surface of the earth. You can find nuggets of gold, you can find nuggets of silver, and you can even find nuggets of copper. And that's how ancient civilizations began to use metals. These were some of the first metals ever used. And then they also started to use lead. The Romans had lead, and I think they mixed it with tin to make pewter. Where's tin? SN. Lead and tin mixed together. They used to drink out of cups made of lead and tin. Yeah.
Don't like when people see like gold and stuff, don't they burn it in a furnace after it turns into nuggets?
Yeah, that's smelting. You can do that to metal to turn it into nuggets. But only when you have ore you do that. When you find little bits of it, yeah, they melt it down.
Like if there's like a diamond, you need like a certain like pickaxe.
For a diamond? What are you asking?
Because like if you see like diamonds on the floor,
Yeah.
something that like deep, don't you need like a certain pickaxe to use it?
Yeah, sure. If you're in a diamond mine, yeah, you'll find them usually buried in special kinds of deposits. I forget what they're called. I think kimberlites. There's special types of deposits because the diamonds are formed very deep in the earth, and then they're brought to the surface by volcanoes. That's how they find diamonds, because the diamonds form like 100 miles down, but you can't dig 100 miles down. You can only dig about, I think the deepest they've gone is about 9 miles, and it was just with a borehole. It wasn't an actual mine. The deepest mines are not more than about 2 miles deep, as far as I know. You can't go. People have this idea from movies and science fiction that you can go down hundreds of miles. You can't. After about a couple miles, the pressure is so high, even in the rock, that it gets dangerous because the pressure from all the rock above and the weight from all the rocks above tends to diminish the size of the hole that you dig. When they pull the drill out of the borehole, where they did it in Russia, it tends to close in again because the rock is under so much pressure and it's hot. It behaves a little bit more like plasticine than real rock. It changes shape. So you have to shore up. When they build tunnels through mountains, they have to reinforce the walls of the tunnel so that stuff doesn't fall in on them again. There's just so much weight above them. It's a scary thought, frankly. Okay, let's look how that looks on the periodic table. I'm just gonna show you how I do it here. So skylayak, I'd like you to memorize because it's a group 3, and it reminds you where the break is. So right after that, you can draw a little squiggly line there, and it'll help you remember that right after that, there's a big jump in the numbers. When you write the numbers on your periodic table, I made a mistake here. Should write these a little higher. Just be aware that this periodic table is not exactly the same as the one I gave you, because since 1973, when this was published, they've discovered more elements. So I'll show you the ones they discovered. You see how this one goes FRRAAC, and then it goes UNC, UMP, UN, and it has these 3-letter names. Those aren't names, they're just numbers. So before in the early stages of the discovery of the new elements, nobody could agree on their names, so they called them 104ium, 105ium, 106ium in Latin. So unilquadium means 104ium in Latin. Unilpentium means 105ium. But later on, they named them after famous scientists or the university where the element was discovered or a famous city. So I'll give you the actual symbols of the new elements. It goes like this: Brayak, Rif, Dib, Sig, Ba, Hus, Mat, Dis, Rig, Cn for Copernicium. I know it up to there. Up to here I know it. There's also names for these ones, I just don't remember them. But there's Rutherfordium, named after Ernest Rutherford, the guy who helped prove that the atom is mostly empty space. Dubnium, I think it's after a university in Russia, or a city in Russia. Seaborgium, named after Glenn Seaborg, who discovered those 10 elements from 93 to 103. Bohrium, after Niels Bohr, who talked about what the electron is doing inside the atom. Hassium, I don't know what he was famous for. Meitnerium was the woman who discovered radioactivity, Lise Meitner. Dysprosium, don't know what they named that after. Rangtenium is after the guy who discovered X-rays. And Copernicium is named after Copernicus, who he was the first one to talk about how the solar system is, the sun is at the center of the solar system. That's what Copernicus said, if I remember correctly. So he was a genius from the 15th century. What else did I want to tell you about that? Yeah, all these elements that were recently discovered, like I said, they don't have any practical use. You can't actually get an amount that you would see, because it's they're so radioactive that you can't accumulate any quantity of them. I recommend that you try to do this now for this weekend. I'll give you this as the homework. Try to memorize column 1, 2, 17, and 18. Okay, so you're going to say H. Linac, rubidium, cesium, francium, and Bemka Cerbera, so columns 1 and 2, the alkali metals and the alkaline earth metals. And you try to memorize FCl Bryat and He Narker Xern. It shouldn't be too hard. And I'll post a blank periodic table if I can. I'll try to look one up. If not, I'll take a picture of it and post it. And you can always print a copy of it and then practice on that. Okay? That'll be on your little homework board tonight. Maybe you should also try another mock test for practice. So you know what you can do? I already gave you, which ones? I already gave you 1, 39, 41, 45, and 49. I'll give you 4 more that you can try without my help to see if you really learned it. Don't worry if you don't know how to do it. It's not the end of the world. But if you can do it, give yourself a pat on the back, because that's impressive for a grade 9. Here, I'll select 4 more questions for you. memorize groups 1 to 17 and 18 in PT, and try numbers 138, 143, 147,